So welcome to my next video. In the previous video we were discussing about the properties of complex conjugate number, and we have discussed about properties number 9. It was going on and the proof was not done. So now we are going to prove z1 divided by z2 whole bar is equal to z1 bar divided by z2 bar. Now let us suppose that z1 is equal to a1 plus ib1, z2 is equal to a2 plus ib2, implies z1 bar a1 minus ib1 implies that z2 bar, this will be a2 minus ib2, where a1, a2, b1, b2 belongs to the set of all real numbers. Okay. So z1 by z2, that is a1 plus ib1 divided by a2 plus ib2. Okay, and implies z1 divided by z2 whole bar is equal to a1 plus ib1 divided by a2 plus ib2 whole bar, that is a1 minus ib1 a2 minus ib2. This implies that z1 bar and this implies that z2 bar. Okay, so we can say that z1 divided by z2 whole bar is equal to z1 bar divided by z2 bar. So property number 9 is established. Now we are going to discuss about property number 10. Okay, z to the power n whole bar is equal to z to the power bar whole n. Okay, let us suppose that similar method, let us suppose that z equals to a plus ib, implies z bar is equal to a minus ib. A and b belongs to the set of all real numbers. Then z equal to a plus ib, we are writing repeatedly, that is then z to the power n bar, that is a plus ib to the power n whole bar is equal to a minus ib to the power n, because this sign is changed by the presence of the bar. Okay, so we may say that z bar to the power n. So property number 10 is established. Now property number 11, this is z1 z2 bar plus z2 z1 bar is equal to twice of real part of z1 bar, z2 is equal to twice of real part of z2 bar z1. Okay, so now we are going to prove this theorem. Similar method, let z1 equals to a1 plus ib1 and z2 equals to a2 plus ib2, where a1, a2, b1, b2 belongs to the set of all real numbers. Okay, now what is going on? z1 into z2 bar, z1 z2 bar plus z2 into z1 bar. So ay plus ib1 into a2 minus ib2 plus and a2 plus I b2 into a1 minus I b1. Okay. Now a1 a2 minus I a1 b2 plus I a2 b1 plus minus plus into minus equals to minus I square b1 b2. Okay. Plus a1 a2 plus a1 a2 minus I a2 b1 plus I a1 b2 minus I square b1 b2. Okay. So we are cancelling I a1 b2 minus minus, and this is going to cancelling. So we obtain a1 a2 twice, because there is a1 plus a1 into a2, and here it is a1 a2. So if we sum them up, then we obtain that 2 a1 a2. Okay. And this minus 2 I square b1 b2, that is 2 common, a1 a2 plus b1 b2. And suppose R E Z z1 2 bar equals to, now obviously I b1 a2 minus I b2. Okay. a1 a2 minus I a1 b2 plus I a2 b1 minus I square b1 b2. 2 plus b1 b2 a2 b1